Hi, I'm Megan Daw, and I supported much of the work for Palo Alto's REACH Code Cost Effectiveness Study. Today we'll be going over the residential measures in a little bit of detail, as well as how you can model those in California's compliance software. So hopefully you can use some of these measures in your projects to comply with the ordinance. All right, so now we will get into details of these measures we used for the REACH Code Cost Effectiveness Study, details of each measure, and how you can effectively model these in the current California simulation software. The REACH Code for residential new construction has two pathways for projects to meet the ordinance. The first is if a project is not going to install PV panels, you have to meet 10% compliance above Title 24. If a project wishes to install PV panels for single-family residential new construction, your project must meet 20% compliance above Title 24 and 12% for low-rise multifamily. I'll be focusing today on measures that can help achieve the 10% compliance margin. I'll also talk about how you can use PV in the simulation software to meet the 20% for single-family and 12% for low-rise multifamily. I'll go over the methodologies, so the software we are using, and the sources of each of the measures we're modeling. For each measure, I'll give a brief description of the measure and a live demonstration of how to model this in the compliance software. We'll then look at the impacts of each measure as we apply them to a single project. The residential measures are quality insulation installation, commonly known as QII, HERS piping installation for all of the hot water lines, refrigerant charge verification, and for low-rise multifamily, we also looked at drain water heat recovery. Finally, we'll go over some of the conclusions and additional resources and links to resources that I talked about during this presentation. The software we used for the REACH Code study and that I'll be using today is CBEC RES, and that stands for California Building Energy Code Compliance, RES for residential. The version we used is the 2016 1.0 version. The software is constantly updated, and there might be a newer version released prior to the effective date of this REACH code. In this modeling software, it's used for all types of low-rise residential buildings, so single-family and low-rise multifamily. Other approved software that users can use to comply with Title 24 and the REACH Code ordinance include Energy Pro and Right Energy. A little overview of how CBEC RES is set up and how you can effectively use it. There are two main tabs when you open up the software, the Envelope tab and the Mechanical tab. In the Envelope tab, you can lay out your building geometry and provide building characteristics such as number of floors, square footage, and you also build all of your different floors, different stories, your external or exterior surfaces, windows, and down at the construction assembly is where you actually build all of your construction assemblies, such as your exterior walls and roofs that you will use in your project. On the Mechanical tab, all of our HVAC systems and hot water systems are built, and each HVAC system has a heating, cooling component. The distribution type for our project, we're using a duct distribution, as well as your water heater. After building your project and running the simulation, you will get the results and a breakdown of how the results can be used. On the left-hand side, we see the standard design. So this tells you how your project would perform if all of the prescriptive requirements were installed. And on the right side is our proposed design that takes into account all of the energy efficiency measures that we are going to implement in our building. And you have your compliance total here, your compliance percentage, and that's how you know how your building is performing in comparison to a standard design building. This is just an example, and we'll go through each of the measures. For today, we will be using the single-story, single-family home for the residential modeling. This is a California Energy Commission standard prototype building. You can find the details of this in the joint appendices, as well as the Residential Alternative Compliance Manual reference manual. And this building is built in California Climate Zone 4, which is where Palo Alto is located. It is starting out exactly compliant, so we are using all the prescriptive requirements, and then we'll show how each measure will then get your compliance margin to increase above that standard. I won't be going into the exact details of how to build this model, and you can refer to the Residential ACM reference manual for those details. One measure, as I mentioned earlier, the drain water heat recovery, we only looked at this for the low-rise multifamily prototype. So here are the details of that prototype. It's a 2-story building with 8 units, and I will describe how we estimated the savings for the drain water heat recovery. But this will be the only measure we use that low-rise multifamily prototype for today. The measures we're looking at were those that we included in the REACH Code cost effectiveness study. And we got to these measures after looking at various measures and determining that these were both technically feasible and cost effective. The residential measures are QII, HERS pipe insulation, refrigerant charge verification, and again for low-rise multifamily, the drain water heat recovery. The simulation results we're going to see today might be slightly different than what are in this report, and that's because the report actually used a blended simulation results from both a 1-story single-family home and a 2-story single-family home, as we thought this was more representative of the building construction in Palo Alto. Additionally, the simulation results you're going to see today might be different than those you get when you simulate these same measures if you're doing it in a later version or different version of the simulation software. Again, we used 2016 version 1.0 today. And lastly, drain water heat recovery is not currently able to be modeled in CBEC Res. I'll go over briefly how we estimated those savings and what you can do to show compliance with this particular measure if you choose to use it. The first measure is quality insulation installation. What this does in your building is verifying that the insulation is properly installed, that there aren't large gaps and room for air to move back and forth through your wall assembly, your roof assembly, and your floor assembly. And what it does effectively in the model is actually increase that insulation assumption for all of your exterior surfaces. The default in the model without taking QII is it actually reduces the insulation value in those assemblies. This measure does require HERS verification, and you can get the details of that testing protocol in the reference appendix RA 3.5. So we'll jump into the model and show you exactly how to model this in the software. So here we have our single-story residential single-family home, and this model started out perfectly compliant, so 0% compliance, and how we're going to include QII is in this main project tab. You will go to the building, and in the installation construction quality, you will actually select improved. And this is telling your model you are doing the HERS verified QII. You select OK, you save it. If you don't save it, it'll prompt you to save it, and then you run the simulation. As you can see, with just implementing QII, our single-family residential building has already reached 9.1% compliance. So that's a huge boost. We're aiming for 10%, so there are a few more things we're going to need to do to get there. So as you can see, that measure got us to 9.1%, and we have a few more things we're going to need to do to get ourselves to 10% for this project. On this table here, I'm tracking each measure and how it's reducing our TDV kBTU per square foot. Each measure we implement will reduce that TDV kBTU per square foot value and increase our percent above Title 24. The next measure we looked at is HERS pipe insulation for all of your hot water lines. This measure requires insulation be installed on all hot water pipelines between the water heater and the end-use fixtures. This mostly is impacting those pipes that are 1/2 inch in diameter and less. The insulation thickness is dependent on both the pipe diameter and the temperature of the water being transported through those pipes. More details on that can be found in Table 120.3a in Title 24, Part 6. This measure also requires HERS verification, and you can find the details of those protocols in the reference appendix RA 3.6. Let's jump back in the model and see how this affects our building. So we'll go over to the mechanical tab, and in our domestic hot water system entry, we will change the dwelling unit distribution from standard to the HERS parallel pipe, we'll change it to the HERS pipe insulation all lines. We will save it and run the simulation. We've now reached 10.9% with both QII and the HERS pipe insulation measure. So let's go back to our building. And you can see with these two measures in this prototype, we've already achieved the 10% compliance. This won't be true maybe for every project, and the 2-story residential project, you might have to install another measure. So we'll look at the refrigerant charge verification measure as an additional single-family measure to meet this compliance. In the refrigerant charge verification, this is a HERS verification test where your HVAC contractor will ensure that the proper charge to your, I'm going to restart that. For the refrigerant charge verification, this measure ensures that your HVAC system is properly charged. Overcharging or undercharging a refrigerant can cause several inefficiencies and actually potentially reduce the life of your system. The details on this testing protocol are available in the reference appendix RA 3.2. We'll get in the model and show you how this affects our building. So we'll go back to the mechanical, and in our cooling component, then this measure is available for air conditioners and split heat pumps. The AC charge will change from not verified to verified, and this tells the model you are having your HVAC contractor as well as a HERS rater come and verify the correct charge for your system. And with that measure, we've now achieved 11.3% compliance with all three measures, the QII, pipe insulation, and refrigerant charge verification. So you can see here that our TDV kBTU has reduced as we've added on measures, and our percent compliance has increased as we've added on measures. Lastly, for the low-rise multifamily building, we also included drain water heat recovery because the three measures we previously described did not quite get us to 10%. Drain water heat recovery is a measure where you install a heat exchanger on a drain line, and this is able to transfer some of that heat from your drain line to your cold water lines that are leading to either your water heater or the cold side of your fixture. This technology can be applied to either individual water heating systems or central water heating systems. For our prototype, we had individual water heaters for each dwelling unit. As mentioned before, this is not currently available in the CEC-approved software. In order to comply with this measure, you will need to indicate on your plans the number of water heaters installed and the number of water heaters that are connected to the drain water heat recovery system. Palo Alto will determine the reduction to the domestic hot water energy use by calculating the proportion of water heaters that are able to utilize and benefit from the heat exchanger. I won't get into the details of exactly how we determined the energy reduction to domestic hot water, but here we can see that for low-rise multifamily, we saw a reduction in the TDV kBTU, and achieved 10.2% energy compliance. Lastly, the second way to comply with Palo Alto's ordinance is to install PV. Effectively, an applicant could install none of these measures and implement PV in their project and show a 20% compliance credit for single family and a 12% compliance credit for multifamily. Let's see what this looks like in the model. So we're back to the model where we are perfectly compliant with Title 24, so 0% compliance margin. When you go to your building tab, under the analysis section, you are able to insert a PV system. For single family, the minimum installed PV system here is a 2 kilowatt, and that is on DC. You hit OK, you save this, you run the simulation. As you can see here, we have no compliance margins for any of our end uses, but we do receive a PV credit of 5.5 KTDV, and that equates to a 20.1% compliance margin. So just by installing PV on this project, we have met Palo Alto's REACH code ordinance. How this compliance credit is calculated is that CEC is allowing in 2016 Title 24 for projects in certain climate zones to take compliance credit for installing PV systems. The credit is calculated as being equivalent to the TDV kBTU value of high-performance attics and or high-performance walls, where they are prescriptively required. In Climate Zone 4, where Palo Alto is located, both high-performance attics and high-performance walls are prescriptively required. The maximum compliance credit for this project is 20% in the single family and 12% for the low-rise multifamily. The minimum installation is for a 2 kilowatt direct current system, and for a low-rise multifamily, that is an 8 kilowatt direct current system. We can see here we started with a code-compliant project. We installed the PV system, received the PV compliance credit, and achieved a 20.1% compliance margin. In conclusion, the package of measures I presented today can help you achieve the 10% compliance margin for the Palo Alto REACH code. However, these are not the only measures you can use to reach this 10% compliance margin. You might also want to consider changing some of your envelope features, such as your window U factor. When that is changed to 0.25, we receive 7% compliance margin, which is more than halfway to the 10%. You can also look at increasing the efficiency of some of your heating and cooling systems. When we increased the furnace efficiency and the air conditioning efficiency, we also achieved a 7% compliance margin. Lastly, you can look at installing solar thermal for your domestic hot water. Measures we wouldn't consider for complying with the ordinance are lighting and appliances. CEC has made it so that Title 24 does not consider any efficiency gains for lighting and appliances. Your standard design will always be equal to your proposed model, and we can't gain any efficiencies in those areas. A last note is for 2016, the PV compliance credit that I just went over is not guaranteed to be available in later versions of Title 24. The compliance credit results in TDV kBTU savings and has a maximum threshold as we described. In 2016, there's also the energy design rating. And this rating is a scaling measurement that shows how your building is doing in comparison to a reference building. PV is given full value in this calculation. The PV compliance credit value that you receive in the model may actually be smaller than the PV system you are installing. The energy design rating calculation takes the full value of the PV system and is calculated separately from energy efficiency. Lastly, here are the resources I talked about today where you can find more information. CBEC Res is the modeling software I used. The Reach Code, a cost-effectiveness study, where you can find more details about each of these measures and the costs and energy savings for each measure, is available online. The Residential Alternative Calculation Method Reference Manual provides more details on the prototype buildings and how to model additional measures. And the Joint Appendices also provide some details about the prototypes we use today. I hope this was useful and that you can use some of these measures in your projects for Palo Alto.